But this page over here, we're going to talk about page 71A. Okay, so solve the following quadratic equations by completing square. First of all, do you understand what it means by completing the square? Okay, so basically, it's just we see quadratic function. We wanted this to be looking like this, right? This is called completing square. Is that you're creating the square out of nowhere, and you have to know the strategy.
Wait, I know how to do this.
You know how to do this. So well, do you know how you get the 3/8 from?
Um,
And do you know why is there 3/8 to the power of 2 here too?
no.
Okay, so let me go through that. Okay.
Okay.
So the strategy in general is that first we would categorize these two parts, x squared plus 3/4x. We would move the numbers with a constant 1/16 to the right side. That's okay, right? Perfect. Now, how do I get the 3/8 to the power of 2? This is actually essential for us to creating the square. One of the strategies I always tell you guys is that take a look at this number, which is 3/4, right? Take this number out, divide this number by 2, right? So this is step number 1. Step number 2 is whatever answer you're getting from here, square it. And that will be the stuff that you need to add it to complete the square. Because the idea of that is when you look at a perfect square formula, when you expand it, it's 2xy, right? Plus y squared. And this 2 is actually the 2 that I divided by. And this number to the power of 2 is actually the y squared that I added to. So which means that if I'm creating a square, I'm actually creating something from a thing there, and I need to subtract it back. I'm assuming that we do not have this yet. Okay, anyway. So going back to this question over here, if we're adding the 3/8 to the power of 2 on the left side, right? This is the left side, this is the right side. And I'm assuming that I'm going to do the same thing for the right side too, right? Perfect. So does this make sense to you that after all, I'm able to have a perfect square of x plus 3/8 to the power of 2 because I created the square from scratch? Then on the right side, all I need to do is I just need to use the 1/16 plus 3/8 to the power of 2. Same number here, right? And I get 13/64. And last but not least, I have to solve it by square root the 13/64, which I get positive, negative. Don't forget about the negative and positive part, right? Of root 13/8. Then I just I subtract this 3/8 to the right side, which I will get -3 plus or minus root 13. Okay, any questions for this? Right, should be pretty straightforward as long as you know how to complete square. The challenge of these pages are actually in 72B. Okay, let's dive to it. And guess what? Does this look familiar to you? What is this called?
I don't know.
This is called the quadratic formula. And the quadratic formula is actually created by completing the square. So let's see how we actually complete the square for this one. Yeah, ready? First step is I see this is my standard polynomial form. What is the standard polynomial form? Is that we have the highest degree, then the second highest, and then constant for the quadratic function. Okay. Do you know what the highest degree means?
No.
Highest degree means that x to the power of, this is the most, right? We always have it first with its coefficient. You know what a coefficient is, right? The letter or number before the highest degree variables. In this case, what's our variable? It's x, right? X is our variable. And this is bx. This is c. So a, b, and c, those numbers are my coefficients. Okay? Any question up until now? Now, let me ask you this. How do I get to this point?
Divided by a.
Everything divided by a, right? Perfect. So no problem with that. And how do I get x squared plus b/ax equal to Negative c over a.
The c over a change it to 0.
Very good. Change it to the right side, you mean. Okay, not 0. Now, do you know where I get this b over 2a squared from?
Divided by 2.
There we go. We take this b over a out, right? B over a divided by 2. That's my first step. And then my second step is that whatever answer I'm getting here, which is b over 2a, I square it, right? That's how I get the b over 2a to the power of 2. And that's also how I get the b over 2a to the power of 2 on the right side as well. Good. Now, next, does this make sense to you that we have a perfect square now? Because that we completed a square, right? For x squared plus b over 8x, okay? And on the right side, does this make sense?
Yes.
Because that we open the bracket for this, b squared, and there's 4a squared underneath, right? Now, we just have to find something called the LCM on the right side. A and 4a squared, they share the same LCM at 4a. Because this does not have the a squared, right? So we multiply the top by 4a. So then that's how you get the negative 4ac on the right side now, because this was a negative number, right? Over here, this was a negative number, right? This was a negative number here, right? Okay, now, next step. All right, next step. I have this b squared minus 4ac over 4a squared. I can't really reduce this, right? So what I'm going to do is that I'm going to solve for x plus b over 2a first, which I just need to square root this guy.
Top part.
All right. No, not only the top part, also the bottom part too.
Oh,
But because
perfect.
bottom part is 4a squared, that's why when I square root of it, it would just be 2a. All right. So does that make sense that we have a root b squared minus 4ac? Right? Perfect. Now all I need to do is what? Just to subtract this b over 2a.
No, but why don't I like over here? It was like 4ac. Then I can so I can make it into 2ac.
Why do you want to make it into AC? Oh, you're saying this 2a over here, you can reduce, but you can't really reduce with the b squared though, right? So in this case, it's b squared minus 4ac, right? Like that, right? This is what you mean. You can't just do all the 2a and this would be 2c because
No, like I mean like so I square root the 4ac, so it becomes 2ac.
oh, you mean here? But then you
Like,
can't really square root of AC though.
So
You can't. So in this case, you are actually square root of this whole thing. This whole thing. Unless you're doing, for example, something like this. Unless you're doing this. But let me ask you this. Does the rule of square root apply to this? Absolutely no. Why? Because if you wanted to do something like this, in between it has to be it has to be a multiplication or division instead of a subtraction. Because subtraction and addition is the lowest tier of the order of operation. That's why you cannot do that. Yeah? Make sense? All right, last but not least, you subtract the b over 2a to the right side, right? You reorganize things. That's where you get the negative b over here. So this, if you were to remember this is one of the most important formula throughout high school. And you will need it even in universities. This is how you actually find the roots, find the answers for x. Okay. So for example, let's say I have x squared plus 3x plus 4. Okay. I'm just, again, throwing out numbers over here. Okay. You can literally substitute. So in this case, a is equal to 1, b is equal to 3, c is equal to 4. You can substitute these numbers into this formula over here, and you will get your x. And your x should be 2 values, right? Or sometimes only 1 value, or sometimes no value. And the specific details, we'll talk about it in the future when we talk about the quadratic formula. But this page is just telling you that we can use completing square, right, to derive and get the answers for this type of question. Any questions?
No.
No? Good. All right, we can move on, right? All right, let's move on. There you go. Quadratic formula. That's exactly what we're doing over here, right? So this is to tell you that, hey, you know what, you just have to substitute these numbers, right? It even tells you that The A is equal to 3, B is equal to 9, C is equal to 2, based on the 3, 9, 2, right? Again, what we're talking about now is called a standard polynomial form, which means that it starts with a squared, bx, and c. And almost all the question you're doing, as you can tell, is going to be pretty similar to that. Okay? Any questions? Good. So I think all these pages are the same thing, even till now. So that should sum. Oh, there we go. All right. So for this page over here, right, it's asking you to use quadratic formula and factorization. So the chances are you can use both methods to solve the equation, whether it's factorization.
This one is easier.
Also, okay, so if you find this is easier, you can go with the easier one.
So do I have to do this part?
Yes, unfortunately. And then and also you can complete the answers as well, right? But some questions you will know that it's so much easier to just use the factorization.
Can I just do this part and then just write it in?
No. Hey, come on, girl. This is the right attitude, right? Right work ethics, right attitude. It's just do it properly, okay? Yeah, I know you're shaking your head, but no, just do it properly, please. Okay, anyway, let me see. So for these pages, right, you can actually choose your method, whether you use a factorization or whether you use quadratic formula. To me, always factorization. Unless I cannot factorize it, I will use a quadratic formula. Okay? Yeah, so that basically summarizes 80. Any questions?
No.
Okay, all right, so that should be it for today then.